So here should be an if statement, right? If this condition happens, like this, if g of middle is less than 0, we know x should be in the range of middle to high, right? We always, this range, right? We always have the g of low should be less than 0, g of the right part should be always greater than 0. Then we know this value should be in the middle. And as we can see, because middle is half of it, the range of the this value, this range, the size of the range will half each time. And let's see how many iterations do we need to get a good approximation, right? So let's see how we can program it. Erase it. Right. So I will, first we can say we define low equal to 0 and high equals to some number that's greater than maybe 10, right? Anything will be fine. And we can define something like the middle. Wait, it's not an int. It should be a double equals low plus high divided by 2. Let's say, let's make this one a double. So we need a for loop, middle times middle minus 2 should be less than 1 to the power of negative 14. Let's give it this. Right, we have defined the initial low, the initial high, and we define the initial middle, and oh, it's a for we should be a while loop. While loop, right? The condition is wrong. While this one is greater than, right? If the error between x squared minus 2 is greater than some large number, right? We will keep doing this as long as this one approximately equals to 0, this function approximately equal to 0, we will stop. All right, so the question is, what can we do is we need a if statement, right? If middle times middle is greater than 2, or we say minus 2 is greater than 0. Yeah. Then we know x should be in the range of what? Low to, yeah, low to middle. Low to middle, right? It should be in the range of low to middle. Let's put a brace here. We say low, it doesn't change, so our new high becomes middle. Yeah, we don't need to pass or minus. It's fine. And else, right? What we can do is low equals to middle. Because now we say it's in the range of middle to high. Right? Then we do recompute this middle. And we can output the middle after we are done. this is the whole program. We need some libraries, and you type in the libraries. Forget about the format, right? Here is what we basically do.
X and the X and plus it.
Password.
So it's
Oh, yes, yes, we need the number of iterations. Let's make it much easier. How about we see out in the middle, right? Let's see how the middle changes. How about that? All right, let me compile it. Yeah, I believe it's test 2. Show period and run test 2. Yeah, right. It's very close actually. I need to set the precision so that we can see. And maybe this number is too large. Let me make it a small number, -5. Compile it and run it, right? Yeah, maybe it's hard to see. Let's move it here. So as you can see, starting from something that's far away, then we will get closer and closer to the real value of square root of 2, right? So any questions on this? And does it matter if we set the high to be a small number or large number? Right. The initial range. How about the initial range? Let me clear it, compile it, then run it again, right? It may start with something really weird, but it quickly converge to our expected output, right? So the initial value doesn't matter that much. Maybe it will be 1 or maybe 10 iterations more, but it doesn't matter. Yeah, question? The result, which one? 1.207? It's just some number that's computed in the middle, right? Yeah, so at this range, it should be low should be 0 and high should be 2.44. So at that time, when you compute the middle is 1.22. And next time, you know, it should be in the range of 1.22 to 2.44. Then compute the average, which is the middle, it becomes 1.83. Then next time, because you know it should be in the range of 1.22 to 1.83, it becomes 1.52, right? It will becomes it's just the lower range. So this one is the replacement for the initial low. Initial low is 0. Now it becomes 1.22. Yeah, question. Oh yeah, some of the functions, if you forget to include the library, it's okay. It will automatically include it. It depends on the compiler. Yeah, I believe in most of the compilers, if you forget to include that one, you can still use ABS. So we said C++ is cross-compiled across platform, but the libraries are not. Right? The libraries are not cross-compiled. Yeah. Any more questions on this code itself? All right, so you can do a lot, right? Not only you can compute square root of 2, you can compute nth root of any number, right? As long as you can compute the value of your functions. You can replace 2 with any number, so you can get square root of x. Right? You can see in an x, then you can compute square root of x, or you can compute third root of some number, fourth root of some number, fifth root of some number, right? It's called numerical ways to compute these things. No more questions? Yeah, question. Hello to me too. Yeah. So as we said, we need someone, right? We need someone to be the value of gx need to be negative in this part, and some point that need to be positive. Then we can use this algorithm because it needs somewhere it to be negative, somewhere to be positive. Then because it's continuous, we know the x should be in the range, right? We can also find the negative ones, setting low to be -2, high to be 0. You can also compute this point. But you cannot say low equals to 2, high equals to 10. You will never find such a point. Right? It will, I believe it will get closer and closer to 2, but it will never find square root of 2. All right, so if no more questions, we will continue. So one of the errors is called off by 1 errors. So it means when we are computing the number of years, is it does it adding 1 extra year or exactly the same year? Right. If we take 10 years to double our initial values, is a year equals to 10 or is a year equals to 11? Sometimes we will forget about that. So you need to check that.
Initial value.
Initial value? Yes, we can change the initial value. More importantly, you need to understand the logic inside, right? Sometimes you say less than, and sometimes less than equal to. There are multiple ways you can change the values. And that question would be easy. What are the types of each variable? Should the year start with 0 or 1? Right? What's the result? Should the year start at 0 or 1? 0? Yeah, this should be 0, right? If it takes 1 year to double, the output will be 1. And you can test, is it less than or less than equal to? Right? Many of the conditions. And what will be the final value of the year? If the rate is 2%, you can try it out by yourself. All right, so we briefly discussed about infinite rule. It means it will keep running until the program is forced to terminate. So we can say initially we can set year to be 1. Right? Another way to write it, we can say while year is less than 20, we can do something. What's the problem? Pardon? you forgot to increment year, right?
Yeah.
So when you finish one step, year equals to 1, second step, year equals to 1, and it will keep running. It will depend on compiler IDEs. Sometimes it will automatically kill your program. But let me try it in my part. Oh no, I will copy this one. Yeah. And keep it. And then create another one. No, just look at the old future value. No, it's not the one. I don't have any program that's doing for loop, while loop. All right. So let me show you one quick example. While do a plus plus. All right. Okay, here's the program I write that will run forever. Yeah, maybe I don't need iOS string. Okay. Let me see if I can compile it. Yeah. It's infinite loop, right? It's not killing my program. So as you can see, here is our loop. And yeah, let me show you how to stop it. Stop it, you need to control plus C. Then it will be the first character is control. Next one is C. So if it's infinite loop, you can use control plus C to kill your program. And here is our infinite loop, right? While the condition, this condition is always correct. And typically you will see people writing code like this while 1. This is very common when people writing an infinite loop, right? Especially for example in the server. You will never kill your program. You're always waiting for the request from your client. You sometimes will write some code like this while 1, and you are waiting for the computer to shut down, then stop the program. Otherwise, you will keep running. So here is an infinite loop. And here is how to stop it, right? So similarly here, when you run it, it will run infinitely. It will not stop until you type control plus C. So sometimes we say, if we want to read some inputs, right, a bunch of inputs from the users, we would say, please enter a sequence of numbers until, for example, end with some sign, like the $sign or pound sign, and so on. It's called as sentinels. And Sentinel only works if there are some restrictions on the inputs, right? If you allow any type of strings, that will be a nightmare, right? How can you know it will be a sentinel to end the user's input? Actually, there's another way to end user's input. It's called control plus D. And yeah, so let me talk about that later. So some of the common sentinel values are 0 or 1, negative 1. For example, if you ask the user to enter some positive numbers, you can say, okay, please end your input with 0 or negative 1. It's quite common. And you can, for example, doing some exercise, like compute the sum of the sequence of salaries. right? Because salaries are always positive numbers. And if the user input a bunch of positive numbers, then end with the -1, you know the user has finished their input. So here is an example, right? Yeah, I've got to initialize salary with some number. Then we say, while salary not equal to -1, we say enter a salary, -1 to finish. Then we can see in the salary. And if the salary is not equal to -1, we keep doing our work, right? And this is the whole block for the while loop. If the input is -1, we know we will jump out of the while loop. And at the end, we can compute the average, right? After computing the count, then we can compute the average. Yeah. So let's try this one. It's good. I don't have line numbers, so I can easily copy it. Yeah, I need to define the initial salary. Salary would be double. But it's not double. It should be int, right? Let me see. I can give it some initial number. Then see out average. What's the problem up here? Wait, let me write down the count. What's the problem of computing the average? Yeah, it's dividing by 2 integers, right? Right. Oh, I haven't defined the sum. Int sum equals to 0. Another way is I can define sum to be double. Let me see, can I compare it? Errors, seeing, all right. Using namespace std. Compare it, yeah, no problem. Right, please enter a salary, 91 to finish. I can write like 3, and it will keep asking me for a -1, right? And it will compute the averages 3, right? So here we say this -1 is our sentinel. We keep getting this input until we read a -1, right? We can finish this whole loop. And otherwise, we just keep adding to sum. And as we said, this division, because it's integer by integer, so the result would be 7 divided by 2 equals to 3, right? We need to define the sum to be double, so that it will be a double division. Then we can recompile, run it, 3, 4, -1. Then we get the average salary, right? Any questions on this? So here is how we control this input, right? If we don't know how many numbers the user will input, right? We don't know how many salaries will they input. We don't know, sometimes we don't know how many, for example, if we ask the user to type in the whole novel, right? We don't know how many lines do they have. We need to use a while loop and asking them to give some of the sentinels to say it's the end of my input. right? Please deal with the remaining. So that's basically the idea. Yeah. Right. So another way of processing a sequence of input is using, for example, control plus D in Linux or Unix or any Unix type of operating systems. Control plus D means it's the end of your input. In this way, you don't need the sentinels, right? You can use control plus D. Then let me see if I have any examples. Yeah, here is the examples. So we can first see in some number, right? And in here, in while loop, we keep adding more numbers. And we put cin enter next to these while conditions. Because cin into some place, it will return. You can think of it as return something like the Booleans values, right? It can be true or can be false. It can fail or it can success. If it is success, we will do more work. If it fails, we jump out. And how can the user says it's the end? It types in control plus D, then this cin will end it, right? Let me rewrite the existing one. So how can we rewrite this one? We can say, how about cin salary, right? And we don't need -1 anymore. Just end the salary, maybe control D to finish, right? And we don't need cin again. This one is not needed. This one not needed. Counter increment. Yeah, something like this, right? We can use a while loop, checking if the input is successful. Then we say if it's is it good to put it here? Maybe you should put one outside. I still need one line inside. Yeah. All right, let's try. Clear it, compile it, run it, right? Enter salary, like 3, like 4. Then I can type control plus D, right, to finish. Then it will output average salary is 3.5. It doesn't show anything, right? When I type control plus D, because it's consumed by this one. It will reading the control plus D. It knows the cin ends. Any questions on this? Yeah. Yeah. Sometimes it's good to put a new line here, right? Otherwise, it will be confused with the previous one. 3, 4 again, control plus D, and finish. So in this way, we don't need a sentinel. We don't care. So initially, when we say -1 is the salary, right? -1 is the sentinel, then you cannot use -1 as the real salary. What if someone salary is really -1, right? You should pay the company $1. How about that? Then it will be a problem. So using this way, we don't need sentinels. We don't need to care about what should be correct values. Any questions on this? That's about input. Yes, question. Sentinel? Okay, it's like if I ask you to give me a bunch of numbers, but I don't know when you will stop, right? So I can use an infinite loop, keep waiting, keep waiting, keep waiting. Any number you type is correct. So we need to agree on something like -1. Whenever I type -1, it means I ended my input, right? So that's called a sentinel. So it's like someone standing here always represent the end of the queue. Like if it's a queue, it's the end of the queue. I say I'm -1. I am the end of the queue. Then you read all the numbers in front of me. Right? So that's the sentinel. So the question is, using sentinels, right? Sometimes we'll say, how about I don't use -1 as sentinel? How about I use a question mark as a sentinel? Right? You cannot do that because you are seeing an integer, right? You have to use some integer as the sentinel. So that's the question when you are specifying the exact type of the CA. Any more questions? No? All right. So that's because you don't know how many numbers the user will input, right? Yeah. All right. So next one is the for loop. For loop is actually the most common one. It's not the while loop, actually, it's the for loop. So for loop, so if you convert for loop to while loop, it's like this. I first set some start values. Yeah. Then we say while I, let's say n plus I. That will be a very common way to write a loop. Yeah. And this loop, we give it a simple special form, which is for loop, right? The initialization, condition, incrementation, like this. So we finish everything in just one line. All the dots can be put here. So they are exactly the same. For loop and a while loop. And actually, you can optionally define new variables inside it, right? Int I equal to start. So it means you cannot use int outside of the for loop. This int is just defined for this block. We will talk about the scope when we cover that. Any questions on this? Simple format, right? But more questions come because we in the compiler it only says this one is the initialization statement. Remember, it's a statement. Then it's a condition expression and it's an updated statement. So they didn't say, so compiler will not check if this initializing I, is it comparing with I, is it updating I? Compiler will never check that. What you can do is like this. For rate equal to 6 and month minus month. Probably I did something wrong. No. Yeah. First, I initialize rate to be 6. In the condition expression, I said month minus. It can also be evaluated to be true or false, right? In the update, I see in some values. You can always do that. The compiler will not complain. But it's not wrong. It's a bad habit to do that. Always do some related work in these expressions, right? Do something that's only related to the index of the for loop to do the work, right? Some bad styles. Continue. Initialization, you can say, okay, how about this output saying, okay, please enter some input, right? In the expression, we say cin, because we know this one can be evaluated to be true or false. Here, we can update the sign. It can actually work, right? Yeah. And it will, what it will do? See out input, this one will be executed only once. Then each time we will check this expression, we will keep inputting x. As long as it's not stopped, we add it to sum. Then we check seeing x again, add it to sum. We check and we seeing x again, add it to sum. Right? Any questions on this one? Initialization runs only once. All the others for every loop, right? It's exactly the same as this while loop. I equal to start will run only once. I less than equal to n will be checked for every loop. I plus plus is inside it, so it will also be executed every step, right? So that's the format of for loop. It's a bad one. It can work, but it's a bad one. Bad style. Another one is the. It's actually not really that right, but sometimes you will confuse the readers, right? So your loop index is I. Your input is a SS is a string, right? You want to visit every character of a string, so you say is SI equals to pound, right? Then so you do something like this. You visit from the first index of a string until to the end. We will talk about this later. So the question is, you're updating the loop index inside your loop body. How many times will I be executed? It depends on the condition, right? If the condition is true, if it's true, condition will be the I will be incremented by 2. Yeah. If it's false, it will be only executed by once. Sometimes you need this kind of style, but it will confuse the readers sometimes, especially when the codes are very long, and then this one are hidden inside some of the code, and it will be a problem. Another one is actually for integers, right? For these integers, we can also use not equal as your conditions checking. For example, if the for this one especially, I equal to 0, I not equal to s less than -1, for instance, and plus I, it can work. But for a double value, don't use not equal, right? We said it has some approximate errors, runoff errors. Don't use not equal. For doubles, always use the less than or greater than, something like that. All right. How many iterations does this one take? First one? Good. Yeah, that's correct. B minus A minus 1, right? So, is it correct? No. No.
Oh,
Yeah, it's B minus A. Yeah, let's look at next one. How about starting with 0, less than 10?
Yes.
How many iterations do we take? 10, right? Yeah, because it's 0 to 9, it's 10 rounds. So similarly, in here, it's B minus A, right? Yeah. It's similar to the plus year round off by 1. You don't know how many iterations, right? Sometimes +1, sometimes -1. How about next one? Eight. Yeah, it should be 20 divided by 3. Yeah, let's count. -10, -7, -4, like that, until it's less than. Yeah, you guys can compute that. How can we write a for loop to print this? We want to print equal n times. No, we want to print the vertical bar n times, and they are separated by equal, or rather for loop to do this. Yeah, I equals to 0, and less than n. Okay. Yeah, you can test this one. It's an exercise, so most of the exercise in the future I will not show the examples. And rewrite them into a while loop. It'll be easy, right? We put I equals to 1 to here, then while I less than 10. Inside the while body, s equals s plus I and plus I. Right? We can rewrite every for loop to a while loop. We can also rewrite every while loop to a for loop. This is another exercise. Write a program that prompts the user for an integer, and then print out if the integer is a prime number or not. How can we test if a number is a prime? Yeah, we need to implement the test prime function, right? Let me see if I have one. No, I don't. Do I have time to cover all of them? Yeah, let me quickly cover one. So how can we test if a number is a prime? If we have a number called num, right? We can use a for loop. We can start from I equals to 2, right? I less than number plus I. If number mod I equals to 0, it means this one is a false. Let me create another one. Is prime equals to true, right? I would first assume prime is a number is greater than 2, right? If it's less than 2, it's easy to test. If it's greater than 2, we can test it like this. We iterate from 2 to 3 to 4 to 5 until number minus 1. We check if number can be divided by this I. If it's true, then it's prime or false. It's not a prime number. Right? This will be a very easy for loop. Any questions on this? No? All right. And what's more is like we can also ignore some part for the for loop. Int I equals to 2. Yeah, so int I equals to 2. Do something like this. The initialized form statement is empty. We can also do that. We ignore this part. We can also ignore the right part. This part can also be ignored. And then we can update I here. Right? We can also do this. Indeed, this one will be exactly the same as while loop. What's the benefit of writing it as a while for loop? So any questions on this? No? All right, so next exercise will be actually much easier, right? Write a program that prompts for 2 integers. Then print out the GCD, the greatest common divisor, right? Because of the time issues, I will not cover it here. You guys can go back and ask ChatGPT, it will tell you. Yeah, it's very, very popular questions, actually. All right, so another one that's used less frequently is called the do-while loop. So in a while loop, we will check first. But in do-while loop, we will do first, then check. So it's just the inverse. So for example, in here, so in a while loop, the diamond is before everything, right? We will check the condition. But in here, diamond is after everything. We do the work once, then check. Is the value less than 0? If true, we go back and do the work again. Otherwise, it will jump out of the whole block. So as you can see, similar to the while loop, the difference is the while loop is at the end. But you don't need to know this because it can easily convert into a while loop. I rarely use this one. Jump statement, yeah, the things you guys are interested. So jump statement let you jump out of the loop, right? The break can leave the loop. It means leave. We have continue. We just skip the current loop, current iteration. Right? We will continue with the next iteration. We didn't jump out of the loop, similar to the break, but we just skip the rest of the current loop. And then the go-to, we said you can jump to anywhere, any label you have specified. We won't use that. For the first two, let's see break, right? Here we have a break statement. This is the for loop. We initialize and with 10. In each step, we -1, and we will check n greater than 0. So it will run 10 times, right? It will run 10 times. And we will see out n. Whenever n equals to 3, we will say this countdown aborted, and we will break. It means it will output 10, 9, 8, right, until 3. We will output 3, then break. Right? So this is a break. Break means jump out of the whole for loop. What if there's another for loop outside of the for loop? What will we do? Jump out of the current for loop, jump out of all the for loops. Current, right? Yeah. It only jumps out of the current for loop. If there are multiple for loops, then it only jumps out of the current one.
But the break is in the curly bracket.
Yeah, it's okay.
It's okay.
Yeah, break only works for this type, right? Loops and a switch, right? Switch can also jump out. So if it's inside a switch, it means jump out of the switch. Then it's actually checking the outside, right? Checking the first outside, is there a switch or for loop? No. Checking the second outside, is there for loop? Yes, then we jump out.
What is the first of the loop and the switch?
What's the what? Oh, okay. There's no priority or precedence on that. It's actually depends on the nearest one, whether you are inside this block or that block. Remember our sentinels, right? We will end with a -1. You can rewrite it using using infinite loop and a break statement. Whenever user input a -1, you break out of the loop. Here is what it looks like, right? While true. And sometimes you will say while true, sometimes you will say while 1 to define an infinite loop. And then how can we jump out? Jump out is in the break. So we ask the user to input a salary. When we get the salary, we compare with -1, our sentence. If it's true, then we break out of the infinite loop, right, to jump out and do something. Otherwise, we will loop inside of the body. So that's another way to use the sentinels and the break. Any questions on how to use break? Correct. Continue. So continue is another type that will skip the current iteration, right? So in here, we still iterate from 10 to 0. Then whenever n equals to 5, we will continue. What does it output?
Except 5.
Yeah, we will print out 10 to 1 except 5. Because whenever we go to here, we will continue. Continue means skip the rest of the loop, right? Go to the next iteration. So that's the usage of continue. Continue is actually very commonly used. Go to, yeah, the bad part of go to. This one is a for loop, right? You guys already know this one is a for loop. If n greater than 0, go to my label. Then n minus 1. Then if n greater than 0, go to my label. Then n minus 1. So it's a for loop actually. But don't use this kind of grammar, right? All right. Any questions on loops? Because I will quickly go to the function part. No more questions? Yeah. Great. So functions. Functions, you can think of it as a black box. Right? It's a black box that takes something as the input and print out something as the output, such as the square root function, right? It computes the square root of a floating point number. If you give it a floating point number, it will give you the square root of that number. It's still a floating point number. And I have also shown you how to implement a square root, right? And also the get line, another function that read a line from the stream, right? So you can think of the functions. So every functions, you can think of them as a black box. You need to think it that way, especially when we go to the recursions. It will be helpful for you. And it's a black box. What's your input and what's your output? So as long as you define this function is well defined. People don't care about how you implement a square root, right? You can implement it using binary search. You can use it implement it using some other ways. And you can always change what's inside the square root, as long as the interface doesn't change. Interface is what's input type, what's output type. So other people's code don't need to change, right? So that's the beauty of writing a function. So many functions that have input values that can be transferred or passed into the functions, right? This one only takes one input. Next one takes two inputs. Means, yeah, it's the power of y. Yeah, and it can be an expression, right? It can be square root of some expression. That expression will be evaluated first, like the b squared minus 4ac. We have in our first example. And in this one, right, compute square root of b squared minus 4ac. This is the main step. In our main function, right, we need to call the square root. So in our main function, we will compute the result of b squared minus 4ac. So all these variables are inside the main function, and the result will be passed to the parameters of the square root. And then the main function will wait here, will be stopped here, and then square root will compute the square root, pass the result to the caller. Caller is your main function. Then the result will come back. And how to use this result depends on your main function. So here is the flows. So any questions on this? It's clear. So here is the typical definitions. You have a function name here. How can you declare a function? You have a function name, you have the return type, you have parameters. Parameters can be empty, then you don't need them. Then you have a statement as the body, right? Like the ABS. how can you implement ABS? Right? It's a function name ABS. Return type is a double. Our input is also a double, right? If the x is greater than 0, we return x. Otherwise, we return negative x. This is the body of ABS.
Yeah.
Right. So this is how you define a function. And after that, people can use ABS.
Yeah.
Right. Right. So this one we have used. It's the future values of if we're given the p is the rate, and let me see, we have the code. All right, and if I have it. Future values. Right. Here is how we define a function. Right. We define a function called the future values. We define the rate p. This is our input, right? And this is our output. We output double. And we can, inside this function body, we can call another function called power. Power is defined in CMAP, right? In your function, you can call another function, you can call another function, and so on. That's what you, what's your question in first class? What is main? Main is another function, right? It takes, here it takes no input, but in the future we can take some input. The return type is an integer, right?
Yeah.
And this is the body of your main function. It's a function. And in this function, you can call another function called the future value. Future value is defined here, another function, function name, get input p. P is now the rate. Rate will be assigned to p. And your output is double. Double will return back and assign to balance. Here is how you can call a function. This is how you define a function. This is how you call a function. Any questions?
What if I write function below? Yeah.
So it depends on the compiler, right? Compiler typically will complain. I never see future value before, right? Normally, when people define some long functions, they will define it in another header file, and they can include that header file in here. So at that time, when you compile, you can see these values. Or if you really want to define it in the same file and you want to define it after this main function, you can use declare and implementations. This is this is 5 lines. All right. But you can define it after, but you need to declare it first. Like this. So from beginning, you declare, okay, in the future, I will implement what is future value. Is a function, but I only declare the input type, the output type, right? So in your main function, you can continue to use it. Compiler will know, yeah, input type is correct, output type is correct. Then you can define the body of the functions. Right? You can say, okay, this is how I implement this function. Any more questions?
The function description only used with
No. You can do anything you like in the functions or outside of functions. You can define any values, any behaviors.
So the return type just define the function.
The return type?
Yes. So you can only return double.
Yeah, because when you say double, you need to return double.
But can you do the calculations like doing integers or in the double function?
It will be casted to double when you return.
Yeah.
If you return a 10, it will becomes 10.0. So that's the C++, right? C++ are strict about the types.
Yeah.
So when it says double, you need to return double. But in some other language like Python, they want to specify that you can return any types. So they won't check the types during the compile time or anything. But C++ will do that. C++, when we say these values, they will check if this value and this value are compatible, can be converted to each other. If yes, it's a valid one.
So why don't we do double calculation in the int main function?
Which one?
Int main.
Int main function? What you need to do?
We can do double calculation in that one.
Oh, you mean return double?
Yes, we can return double.
I believe nowadays the compiler wouldn't allow you to do that. I believe so. Yeah. So in the past, it allows a void. It allows you to return nothing. But nowadays, last time when I tried, it will complain. Yeah. So compilers are evolving. This kind of integers are enough to specify whether the program runs correctly or not. So that's the only thing they need to know about the main function. Nobody will call your main function. Your future values will not call your main function. Right? So main function is the entry point. Any questions? Yes. Yeah, you have to return something. If you specify return double, you have to return something.
You must write or something except for zero.
Except for zero. You mean this function? Yeah, you can do that. Return 1, but it will be casted into double. It will become 1.0.
So the B is not same as
The B? This one?
not same.
It's not the same as what?
The one,
This one?
yeah.
They are the same B. Yeah, they are the same B. It's just some value you need to return. It can return a variable, it can return an expression, right? You can write it in another way is, let me see if I can write it. Right. If you don't want to write it in this way, right, you can return something like this.
Oh,
Then you don't need to return B. Actually, you are assigning some value to B, then return B. You are not returning the parameters, you are returning its values, right? Its values will be copied back to balance.
Yeah. Can we use the same name of parameter or variables in different functions?
Yeah, because every variables you define have the scope defined by the braces. You can use B in here, can be used B in here.
So then
They are different B's. Yeah. Yes.
Why couldn't I define a function multiple times?
Yeah.
Why won't it execute it manually?
You mean define functions multiple times? The same function, the same signature.
But the different executing way.
All right, so functions can only be defined once. It's like a variables. When you define B in here, you cannot define another B inside the same function. They will check the names. But in C++, we have overriding, overloading, which is, let me see. You can, wait. You can define another function, which is the same name. Yeah, you can different types, right? Within the same namespace, you can define the same function name, but different signatures, different inputs. They will execute each version of it based on your parameters. But we will talk about that later, about the overloading or many things. So that's the sometimes it's bad part about C++. Yes. You mean double P here? Yeah, you need to specify what is your type of your input. Your input has to be double. You cannot put a string like the future value quote rate. You cannot do that. You will have some errors. We have double one. All right, yeah. So this is the input type. And this double is the output type. They are different. So your input, for example, when you call this function, this rate has to be double for anything that can be converted into double. It can be integer, then they will be converted into double. Then it will call this function here. And this double means it will return something that's double. You can also, if the signature is not like this, wait, let me remove this one. Yeah. So this type, your functions return type don't have to be exactly the same as your input type.
Yeah.
Right? The input type could be a double, but the output type could be an integer. This is the output, this is the input.
What if I need two like X and Y and input two things?
Yeah, if you need two inputs, you can keep writing here, right? You can input another one, Q. You can have another parameter like the string S and so on, right? You can keep writing. You are saying, okay, your function call need 3 inputs. First one need to be double, second one need to be int, third one need to be a string, and this will be your input. Then your output will be an integer. Right? This is how you define a function. And then whenever you call this function, compiler will check, will they match, will they match, will they match. If anything doesn't match, compiler will complain. Any more questions? Yes.
Can we return more than one value?
No, you cannot return more than one value. So your type need to be, yeah, in the future, we will learn how to return something like a class or a struct that can combine multiple things into one. But that's still one value, right? So you only have one type. And you can basically, you can write many returns, right? You can say, you can do that. You can do that, but whenever it means return, it will return. So everything after this return, it will not execute. Yes.
The sequence of the main function and the function you define influence the program.
No, it won't, because the main function is the entry point, right? Remember? Main function is your entry point, so it will execute line by line from the main function. Then whenever it executes this function, it will jump to here. So whether this one defined before here, before the main function, or after the main function, it will be only executed after line 14. After line 14, I will execute the future value function. If I didn't call the future value function, in main, this function will never be executed. Right? If future value, this function is never used in main function, then this function will never be used. Yes.
So we have 3 very quick, so we need to try to return here.
No. It's just the input. It means when you call this function, right? When you call this function, you need to input something like the. So you need an int, I give you an int. You need a string, I give you a string. Right? Something like this.
Okay, we have 2 things also.
Yeah, that's what I'm saying. You can only return one thing. Function can return only one thing, but in the future we will learn something like the struct class. They can combine multiple things into one, and can return multiple things. Or another way is, in the future we will learn reference, and then this input can also be used as output. But that's future story. So about this is called the signature of a function, right? If it takes 3 inputs, you need to specify 3 of them. It will be copied there. Any more questions? No? All right. So about homework. Yeah, I haven't released it yet.
Yeah.
And wait a minute, I will change it a little bit. So the due date is 2 weeks after now. October 5th. All right, it's October 5th. And you are asked to upload a zip file. It includes files. And let me see if I can show you the questions. So the questions, it's actually very easy for the first one to read, right? And something about that is the first 2 questions you can solve it now, but for the last one, it needs arrays of factors, which will be covered in the next lecture. So you have 2 weeks to solve on the whole problems. The first 2, you can solve it in the following week. Then the last one, you can solve it in another week, right? In your national holidays. And it's actually not that hard, actually. I believe the most difficult thing for you guys are reading the problem yourself.
Yeah.
Yeah, I believe we can do that later. Yeah, we will. Maybe we can upload more test cases. Yeah. So this one, and it's the question itself is actually very easy. And initially we have more questions, and I have deleted some of the hard questions.
Yeah.
So for this one, one of the difficult things about it is reading the problem itself. It will also happen in your exams, right? In your exams. For now, you can go back home and using translators, right? Google Translate. But the question is, in your exam, you don't have translators. You don't have Google Translate. You don't have anything. Then at that time, so you guys need to practice reading English version of problem descriptions.
Yeah.
Right? And start coding on that. So that's that, and we have TA's office hours, and one golden rule is never ask TAs about how to solve the questions. Right? You can ask them to give you more test cases, it's fine, but never ask them how to solve it. They will not answer you. Right? I will not answer you either. Yes. Any questions on homeworks? Am I the first class giving homeworks? Yes. All right. Yeah, that's it for today's class.
我有个问题，如果是比如说像刚刚 salary 那个问题，我不是输了很多，就我不知道它会输几个数。
对。
那如果我想以一个换行来，比如说换了一行，我接下来不想输了，然后我再换一行，我想以这种方式来结束，我应该怎么打？
换行是比较难的，在 C 里面换行，它只会认为你是在等下一个输入而已。
对，但是我换行了过后再换一个行，就相当于
也没什么用，其实。
我不理解。
一般 C in integer 的时候，你不停的换行都没有用，它会一直等，等到你完全输完为止。
比如说我定一个 a 不等于就是
你的 input 你 C in 到一个 integer 里面，
就不太行。
它不会 capture 那个 new line 的那个杠 n 的那个东西。 对，如果你是 capture 整行，那是没问题。比如说你 capture 所有东西，对 get line，把所有东西按照 string 读进来，再去一个一个处理，那是没有关系。
那很复杂。
对对对，
那就最好还是用数字来。
对对对，只能用数字，因为你的 input 就是数字，你 input 到一个 number 里面，你就是一个数字。
这个函数，你们
函数
想函数套函数的情况，就是它的调
函数套函数是调用的
对调用的时候，
调用，
就是要
什么？没有 C 啊？
就是第一个函数你需要是一个数，然后在函数套的函数里面再调一个，
就像这个，
然后你调用的时候
main 是一个函数，函数里面调用了 future value 这个函数。
我的意思是你调用的这个函数，它是一个函数在函数，然后呢，
那不是一样的吗？那
它
你它
被调的
调用它，对，然后呢？你这里有 C out，我这里也可以有 C out，对吧？
它调用的时候是所有是那个函数里面所有都会调用，
都会运行一遍，从头到尾，直到 return 完了才回去执行。
这个是不读的。
对，下面这个是不运行的，只运行到这里，这里运行完以后回到你调用的那一行14行，然后再从14行开始运行下去。
老师，那你这个 double P 定义在这个小括号里面和直接定义在这个大括号里面有什么区别？
这个是 input，我告诉别人我需要3个 input，你调用我这个函数的时候，你需要3个 input。
哦，如果你写在这里面，然后这里面什么都不
空的，那它就可以调
用。
用按照空的调用。
哦，
对。
那如果我把 future value 这个函数放在 main 函数里面的话，那它还可以跳出 main 函数调用吗？
是什么意思？把函数定义放在一个函数的执行里面，
对，
没有这种情况。
哦，
C++ 不允许这种情况。
你这里它这个函数的定义放在它这个后面，它不会运行不了。
不，你要前面有一个 declaration，你要告诉别人我有一个这样的函数，将来我会告诉你它具体是什么，但是你要先告诉他它的 signature 是什么。对。
老师，这个程序我觉得非常神奇，为什么它等于0之后它还在运行这一段？
因为你 salary 是一个 double 永远不要用等号不等号，因为它会有一个误差，它有时候会有误差在那里。
但是我输的就是一个这个整数
对，大概率是会没有问题，但是
就是有问题。
但是按照 double 就是永远不要这样子做，你很有可能会有问题的。
所以它就是 double 它本身有误差，所以不等于，所以是 double 不能用不等于这个符号。
你要减一减小于，比如说1的10的负14次方这样子。
就算我输的是一个很精确的整数，它也会有误差。
对，
好的，行，谢谢。
那个就是 for 的，那个执行顺序，我想问一下，它是先执行下面那个，再执行右边的第3个，还是你把它调出来看一下？我不知道那个专有名词叫。
那应该先 update 吧，
就这个
做一遍。
这个先做一遍。
它是先做这个再做这个，还是先做这个再
吧？
先做这个再做这个。
哦，是吗？
就是
就是
这个，就是一模一样。
先执行这个主代码，再执行这个后，
就加还是在这里，加还是在这里。
还有就是这几天经常能看到一个单引号括起一个大 A 啊，或者小 a， 这个东西到底是什么？
原始字符串
是一个 string 啊，对啊 ，string 或者 character。看我那个有没有？是这个吗？不是。没有掉，是这个是吧？这样子是吧？
对，
这就是一个字符串啊，字符，单个字符。
那它表示什么
啊？就比如说你文本里面写了一个 A， 那么它就是这个 A， 它是一个文本。
那这两个有什么区别？
这个是 string， 这个是 character。
那像有一些什么说大 A 是65，小 A 是97，这又是什么？
那个是 ASCII code，
这个不知道。
所以当时
具体的是半数，
这叫 ASCII table， 对 ASCII 码，它有一个具体的对应。很复杂，你可以去看一眼。
平时有的时候都看到有这种东西，就不知道它是什
么。就是它就是一种就是电信里面，比如说传码对吧？你要传一个 A。你可以规定，比如说65就是 A， 那么你在传65的时候，对方如果知道它是一个 string 的话，它就会自动把它翻译成 A。然后比如说97是小 a， 那么97就这个是一个 ASCII 码，这是全世界通用的一个代码。
就是那其实我要调用它的时候，其实就可以像我说入一个123一样直接写是吧？
对，你可以输入 char x 等于65，那么 x 就是大写的 A。
还有一个就是关于那个 return，我一直不太搞懂这个东西的作用是什么。
return 嘛，return 就是函数结束了，
哦，
就是我拿那个举个例子，
因为它都是这种可输出，只要不是零就不输出。
哦，
这个相当于是当
看这里哈
正确的时候就
main 函数也一样，它也可以有个 main 有个 return 对吧？
当它
就是函数执行碰到 return，整个函数跳出。
那像那个它这里示例有一个就是对绝对值的定义，它是 return x 和 return x 负 x。
对，是的，是的。
这个 return 是表示一个什么？
也是一样。在哪来着？
你知道
这个对吧？
啊，对，
就是我这个函数先进来，如果 x 大于0，我就 return x，我到这里就结束了。就如果后面还有代码的话，我就不执行了。同样，如果跳到了这里，如果它是小于0
，return x 本身是什么的？
别人调用这个函数会调用，比如说 abs 括号-1
啊，
然后-1是小于0嘛，它就会到 else 的话 return 了一个负的-1，
这个函数我的
1。
输出的结果就是负1。
对，是的，
就是其实这个 return 的意思就是我定义这个函数的输出结果。
对对对 ，return 的结果就是这个输出的
你这个函数结束的时候，它还应该输出个什么东西？
是的。
啊。